This is Unit 12, Lesson 3, and in this lesson we're going to be learning about permutations and combinations. Woohoo! Okay, so let's first take a look at what they are and the difference between the two. So a permutation, besides just being super fun to say, well, first of all, in both of these, we're talking about how many different arrangements we can make of something. Okay, if we're given a scenario, how many different possible outcomes are there? So in a permutation, it's important to know that order matters. Okay, so what it says is if you select some items out of a group and the order of the items is important, it's a permutation. Versus when we get down here to a combination, and we'll come back to this, but in a combination, the order does not matter. And I'll go more into detail what that means. Okay, so we have an example. It says we have Anna, Bob, Cal, and Dan, and they're entering a local essay contest. So they can get either first place or second place. Okay, there's two places you can get, and after that, you just, whatever. So in this case, it would be a permutation because order matters. What do I mean by that? Well, if you earn a first place prize, it's very different than earning a second place prize. Okay, coming in first is not the same thing as coming in second. So if Anna and Bob are the two people that earn the prizes, it's very different if Anna comes in first and Bob comes in second versus Bob comes in first and Anna comes in second. So each of these counts as one possibility. So that's two possible outcomes right there. Okay. So order matters because the place that you're positioned in. Right. A lot of times we'll see permutations will be how things are arranged or placed. Okay. We're hanging things on a wall in a certain order. Okay. If I put a poster all the way on the left, it's very different than if my poster's all the way on the right. But the order that something's being done in matters. Also, we'll see problems for permutations where someone's being selected for a certain position. Okay, you are running for an office, a class office. Running for president or vice president are two very different positions. Okay, you're being put into a specific position. So this example is a permutation because order matters. So we say the number of permutations of n items of a set arranged r times is this right here. Now, a couple things to point out. First of all, this formula is on your formula sheet for the SOL, so you don't need to remember it. Okay. There also is a shortcut on the calculator, so we'll get to that shortly, but I want you to understand the formula so you know what's going on. Now, n always stands for the total number of possible people or outcomes or whatever you're picking from, the total number of things to pick from. So in this example, the n would be 4, okay, because there are 4 people that could win a prize, correct? The r always stands for how many spots you're putting them into. So in this example, there's 2 different prizes. The n will always be bigger. I think I wrote that down in here somewhere. Blah, blah, blah. Yes, the bigger number must be first. If it doesn't come first, it won't work out and you'll get 0 as an answer. So if you're like, oh, I don't remember which one's N or R, bigger number comes first, okay? So this one is an 4P2, an NPR. Now, what it means in regards to our formula, we see this exclamation point. And while that means, yes, N, and we're super excited, actually what it is, the exclamation point stands for what's called a factorial. Okay, and what it is, it's the number and the product of all the numbers behind it down to 1. Meaning, in my example here, my n is 4 because I'm picking from 4 different people, Anna, Bob, Dan, or Cal. And so that would be 4 times 3 times 2 times 1. If it was 10 factorial, 10 exclamation point, it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If it was 100 factorial, it would be 100 times 99 times. I'm not going to do that, but you get the point. All right, so my denominator, I would have n minus r factorial. So notice the n minus r is in parentheses, so here I'm really just doing 4 minus 2, because what that does is it takes out, takes into account any repeats and things. So 4 minus 2 factorial will be just 2 factorial, right? And then 2 factorial is 2 times 1. Okay, so I'm just listing them out so you can see what's going on here. So now if I were to simplify this, I could just, multiply the top, multiply the denominator, and divide, or realize, hey, I've got some common factors, woohoo. So I'm just left with 4 times 3. So I have 12 different choices. And this is a small enough scenario where you could actually list them all out. Anna, then Bob, Anna, then Cal, Anna, then Dan, Bob, then Anna, Bob, then Dan, Bob, then Cal, Dan. You get where I'm going with that, okay? But we're going to be working with some bigger numbers where that could just be quite irritating and on the verge of impossible. So Let's take a look at how to do it in the calculator now, okay? So I'm not going to require you to do this by hand, but I do want you to understand what a factorial is. So first of all, let's go to our calculator and figure out where all these things are located. Hold on, it's being funny. Okay. I don't even know what's going on. All right, so turn it on. All right, now for this, we are going into the math and we're going into the PRB that stands for probability because that's kind of where we're at. So there's three different ones we're going to be looking at: choice 2, choice 3, and choice 4. Choice 4 is factorial. So if I asked you to evaluate any number factorial, I should type the number in first. So let's do 100 factorial because I mentioned it and I didn't, count it down. So option number 4, and then when I hit enter, it's going to calculate it for me. That's how big it is. It was too big of a number. So let's cut it down and let's do 10. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 gives me 3,628,800. Okay, so factorials get big quickly, right? Now, the NPR, I don't have to type this in. I can just use the NPR button, all right? But this is what the calculator is actually doing. That's how it's getting the value. So I want to type it in as it's written. So it stands for NPR. N is is the total number I'm picking from. I have a P, and then this is how many items I am picking. So this would be sufficient to show your work. Just write down what you're typing into your calculator. So I want to put that first number in first, so the 4. And then I go over to my menu and I'm going to choose the NPR. So the big thing here is you have to decide if it's a permutation or a combination, which can be a little tricky. So we're going to work on that. And then I'm going to put the 2 and put enter, and it gives me my 12. Okay, so in a permutation, order matters. Combination order does not matter. So we're going to look at the same 2 examples and figure out what the difference would be. So we're entering a local essay contest and 2 people are finalists. Okay, their essay gets pushed on. There's no special prize. It's just 2 people are chosen. Not that one is chosen above the other. It's just 2 people are moving on. So in this case, picking Anna and Bob is the same thing as picking Bob and Anna. Okay, it's not that one gets a prize for being chosen first or second. It's just 2 people are picked to move on. So order does not matter here. It's just a combination. Okay, so the selection of Anna and Bob is a combination of the group of contestants. So if you can imagine, there's going to be less outcomes here because these 2 are no longer counted separately. That's just one possible outcome, Anna and Bob. It doesn't matter whose name I say first. Versus up here, it mattered if I said Anna then Bob or Bob and then Anna because it depended on which prize they got. Okay, so in a combination, you're going to have some less choices. Now the N and R still matter. I have 4 people I'm choosing from and I'm choosing 2 of them. Here's what it looks like in my formula. So I would have 4 factorial, my N. Okay, 4 times 3 times 2 times 1 over N minus R, so 4 minus 2. Okay, so that's 2 factorial, and then R factorial, my R was 2, so like this. Okay, so remember, this isn't just 2 times 2 on the bottom to make that 4 factorial. What this really is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. I'm just going to write this way because that's where my pen started going. So once again, I could cancel common factors and simplify. So 4 times 3 is 12 over 2 times 1 is 2. So I get 6. Okay, once again, you don't have to do that by hand. We can go to our calculator, type in the 4, how many items I'm choosing from, go back to math, but this time choose the option that has the C in it. So option number 3 and put 2 and I should get 6. All right, now you also can type it in. Like I could type in the 4 factorial, so 4 factorial, I'm just showing you that it's the same thing, over we said 2 factorial. So I'm just typing in what my calculator is actually doing when we hit the NCR option. Just to show you what it looks like, okay? And we should get 6 again. Yay, we do. All right, so order matters versus it doesn't matter. Now, important to know that in permutations and combinations again, once an object is chosen, it cannot be chosen again unless specifically specified. But if it's just a regular old 4 pick 2, it's just if you're picked, you can't be picked again. Okay, so the last thing we're going to talk about before some practice is the counting principle. And you've learned about this before. It says sometimes there's more than one type of object being selected in a problem, or an object can be selected more than once. The counting principle is used to determine the number of possible outcomes for an event found by multiplying the number of choices at each stage. So I'm going to show you two different ways to look at this. Okay, so it says a summer camp offers a choice of swimming, tennis, or baseball in the morning, and gymnastics or crafts in the afternoon. How many different pairings of one morning and one afternoon activity can be scheduled? So we're doing one morning and one afternoon. All right, so how many different activities are there in the morning? There's 1, 2, 3. So that means I can pick 3 in the morning. And then I'm going to multiply that by how many different activities I can pick in the afternoon. And I can do either gymnastics or crafts. So that means that there are 6 different possible schedules I can make. I could swim and then do gymnastics. I could swim and then do crafts. Tennis, gymnastics, tennis, crafts, baseball, gymnastics, or baseball and then crafts. Okay, 6 different outcomes. Well, what happens if I said you can pick 2 morning activities? It gets a little bit more complicated there, which we'll see in our next example. So another way to think about this, when I'm only picking one of each, it's pretty basic. Just multiply how many of each option. But really, the counting principle is kind of like multiple combinations. That's how I like to refer to it, MC, multiple combinations. So think of each different each different part of the day as its own. So in the morning, I have 3 options and I'm choosing 1. In the afternoon, I have 2 options and I'm choosing 1. Now, anything choose 1, so anything combination where you're picking one activity, if you did 3C1 on your calculator, you're going to get 3. If I did 2C1 on my calculator, I'm going to get 2. Okay, so you don't have to show it this way. Oh my goodness. I'm just showing you what it looks like. Okay, so you don't have to write it out when you're just picking 1 at each stage of the game. Now, as we move into example 4, you'll see where this matters a little bit more. But 3C1 times 2C1 is just 3 times 2, which is 6. So down here it says Applebee's is running a special family meal deal. You have your choice of 2 of 5 apps. I'm not going to read them because it's going to make me hungry. 2 of 4 entrees and 1 of 2 desserts. So I'm not just picking 1 appetizer, 1 entree, and 1 dessert. If that were the case, if I were picking 1 of each, I could just do 5 times 4 times 2. Okay, and it would give me my answer. But I get to pick 2 out of the 5 appetizers. So I need to do a combination for that. So I have 5 that I'm picking from, and I'm choosing 2. Then I have 4 entrees, and I get to choose 2. Remember, it's a family meal deal. Hopefully not one person's eating all. And then I have 2 desserts. That's a multiplication symbol, and I'm choosing 1. Okay, and you can just type that all right into your calculator. The most common mistake I see people make with this is they add in between as opposed to multiply, and that's definitely going to give you the wrong answer. So please just be careful with that. So 5 choose 2 gives me 10, okay, which is a coinky dink from the 5 and 2, so don't think you just get to multiply. 4 choose 2 is 6. Okay, so I have 10 times 6, and then anything choose 1 is itself, so times 2. So when that's all said and done and I multiply, I have 120 different possible meal selections. Crazy, I know. All right, so what we're going to do right now is we're going to go through and do some practice. What I would like for you to do is to pause the video and just on your own go through and identify if it's permutation, combination, or what I like to, it's counting principle. I also like to refer to it as multiple combinations. They're the same thing. Okay, so just go through and label. So on the side, write like P, C, or counting principle. And then when you press play again, we're actually going to go through the examples, but half the battle is identifying what it is first. So I want you to do that. So pause. Should have paused by now. Okay, moving on. So now you're back here and you identified. So let's see. So it's saying how many ways can 4 posters be arranged on the wall? Well, let's think about this. If we're hanging up our Disney favorites, our Disney classic posters, if Beauty and the Beast is first, it's very different than if because that's on the left side of my wall. It's very different if it's all the way on the right. So this is a permutation. Order matters. Okay, it's how many different ways I'm arranging at different locations. Now, there's only one number here. So let's think about this. How many posters am I putting on my wall? 4. How many different spots is it for them to be? 4. Now, when you end up with a 4P4 or a 5P5 or 10P10, it ends up just being, it's the same thing as 4 factorial. But it doesn't matter. You can just go 4. Well, you know how to do it now. I'm done with your calculator. When you type that into your handy dandy calculator, you end up getting 24. So there's 24 different arrangements. All right, so now I've got those 4 posters, but it's just saying how many groups of 4. I'm not talking about where I'm putting them yet. I'm not talking about where they're going. I'm saying there's 7 posters and I'm picking 4 of them. Later, we'll deal with where they're going on the wall, but for right now, I'm just picking out which ones to hang up. That's a combination. okay? Because if I pick Beauty and the Beast, it doesn't matter if I pick it first or last. I'm picking it. It's part of the group. So this is a 7C4. And when you type that into your calculator, you should get 35. If at any point you need to pause it to do the checking, that's fine. All right, this one we got to think about. A high school assigns each student a 4-digit ID number using the digits 0 through 9. Digits may be repeated, but the first digit cannot be 0. How many ID numbers are possible? So we've got 4 spots to fill. This is a counting principle or a multiple combination because we have certain restrictions on each one. So I can't just say 4, pick 10 because numbers are being repeated. Okay, so remember, because I told you before they can't be, because they're being repeated, we have to think of each digit separately. Okay, and the first digit cannot be 0. So the first digit I can pick from 9 numbers, 9C1, because I can only pick 1 through 9, which is 9. In the second digit, I can pick from 10 different numbers because I'm including 0 again. So 10C1, third digit, 10C1 because I can repeat, and 10C1. So really, I'm just doing 9 times 10 times 10 times 10, which ends up being 9,000. All right, Bill has 3 hats, 5 shirts, 10 pairs of pants, and 6 pairs of shoes. If an outfit consists of just one of each of those things, that's multiple combination or counting principle. So I can do 3C1 times 5C1 times 10C1 times 6C1 because I'm picking 1 hat, 1 shirt, or just realize all those are just going to end up being 3, 5, 10, and 6. So when I multiply all those together, you end up with 900. Go, Bill. 900 outfits. Pretty fancy. All right, number 5, a team plans to choose 3 of the colors from the 5 rings in the Olympics. The colors are blue, black, red, yeah, whatever. How many different combinations? So I'm not putting them anywhere. I'm just picking 3 colors. That's a combination. So I'm doing 5C3 because I have 5 colors. I'm choosing 3. And when you type that in, you should get 10. So in a combination, the closer together these values are, the smaller the outcome. All right, awards are given for the first 5 finishers. There's 12 people. How many different ways? Permutations. Order matters. I'm going to come in first, not 5th or last. It's okay if you do. I'm just saying, I want to win. Okay, so 12P5. 12 people, and I'm picking 5 of them. So when I do that math, we get 95,040. Imagine if you had to do that by hand and list out all the possible options. Whew, crazy. All right, how many 3-letter arrangements of the words in part are possible if no letter can be repeated? Since no letter can be repeated, it's just a good old permutation. And it's a permutation because PAR is very different than I flip that around and do RAP, right? Par versus rap. 2 very different things. So order does matter here. So I'm going to have more combination or possibilities. So I'm picking from 4 letters, and there's 3 different letters I'm picking from. When I do that math, I forgot to do this one ahead of time. 4 math P 3, 24. Okay. Pizza place offers 3 types of crust, 2 kinds of sauce, 10 toppings. All right, once I see I'm talking about different things like crust, sauce, and toppings, I know it's going to be a multiple or a counting principle. So how many pizzas are possible if I have 1 crust, 1 sauce, 3 toppings? So because of that, I can't just do the 3 times 2 times 10 because there's 3 different toppings. So I've got 3 choose 1, which we know is 3. 2 choose 1 for the sauce, which we know is 2, times 10 choose 3. Okay, so it's going to be 6 times whatever 10 choose 3 is. So when I do all that math, we end up with 720 possible pizzas. Excuse me. Sorry, guys. Sorry I coughed. All right, I have 12 CDs, but only 2 fit in my case. How many combinations? All right, this one straight up says combinations. I'm just putting CDs in my case. Small case. So 12 choose 2. All right, when I do it, I get 66. All right, how many ways can a club with 15 members elect a president, vice, secretary, and treasurer? This is a permutation because if I get selected as president, that's very different than treasurer. The amount of responsibility and power are quite different. So 15 members are being put into 4 different positions. So 15 pick 4, and I get 32,760 possible different scenarios. In how many ways can a family of 6 line up in 1 row for photograph permutation? Because if you're standing all the way on the right, it's very different than when you're in the middle. Now, be careful here. I've seen so many people, they just see two numbers and they think that's what I'm working with. I'm lining up in one row. I've got 6 people, but how many different spots are there in that row? There's 6, so it's a 6p6, which is 720. Your biology teacher chooses 6 students from a class with 26 to do a project. How many different groups? So I'm just making groups. If me and Billy are in the group, me and Billy are in the group. It doesn't matter whose name is first, so it's a combination. So 26C6. Oh, don't even have an even number of groups. Anyways, 2,030. 230,230. That's kind of cool. How many 3 flavor blends from 10 froyo flavors? Combination, okay? It's in the bowl. 10C3 is 120. All right, so go ahead and work on the practice on your own. Now, if you don't have your own calculator, you can just identify and set it up. You can do it without the calculator. Now, I do realize some of these are big numbers, so that's not helpful. So worst case, just at least set it up, because once you have it set up, you'll know if you're going to get the right answer or not. All right, adios.